Now we move into the second half of mineral and energy resources. And this part is not just about naming resources. It is about understanding how resources shape industries and how industries choose their location. We'll move through four linked themes. First, nuclear minerals and nuclear power. Then, renewable energy, from solar and wind to tidal, geothermal, and bioenergy. Then the logic of iron and steel, where transport cost decides location. And finally, cotton textiles, where location behaves very differently. Most students study these as separate chapters. Don't. This is one integrated story of resources, power, raw material, and industrial geography. Let's begin with nuclear minerals. India's two key nuclear minerals are uranium and thorium, but they occur in very different environments. Uranium is associated with inland hard rocks. That is why the important uranium zones are in places like Singhbhum in Jharkhand, the Udaipur Alwar Jhunjhunu belt in Rajasthan, Durg in Chhattisgarh, and Bhandara in Maharashtra. The key geological association matters here. Uranium is linked with Dharwar rocks and also with the Singhbhum copper belt. Dharwar rocks are ancient crystalline rocks, and UPSC likes these rock resource linkages. Thorium is different. It is mainly found in coastal sands, especially heavy mineral sands containing monazite and ilmenite. That is why you see it in places like the Mahanadi Delta, Vishakhapatnam, and the Kerala coastal belt, especially the Palakkad-Kollam region as marked here. And the association you should lock is simple. Uranium equals hard inland rock. Thorium equals soft coastal sand. This is where many students lose easy marks by mixing inland rocks with coastal sands. Now move from mineral occurrence to nuclear power projects. The key plants you need to place are Rawatbhata in Rajasthan, Narora in Uttar Pradesh, Tarapur in Maharashtra, Kaiga in Karnataka, Kalpakkam in Tamil Nadu, and Kakarapara in Gujarat. Do not study these as a dead list. Study them as map anchors. Then there is the institutional timeline, and this is a classic trap zone. In 1948, the Atomic Energy Commission was established. In 1954, the Atomic Energy Institute at Trombay came up. And in 1967, it was renamed the Bhabha Atomic Research Center, or BARC. Most students collapse all of this into one date and one institution. That is sloppy preparation. Keep the sequence clean. Commission first, Trombay institution later, BARC name later still. Now shift to the big renewables, solar and wind. Start with solar energy. The solar energy is highly efficient, and there are the two technologies you must not confuse: photovoltaic and solar thermal. Photovoltaic means sunlight is converted directly into electricity. Solar thermal means sunlight is used to produce heat. That is why solar thermal fits uses like dryers and cookers, while photovoltaic is what you use for power generation. Now look at the geography. Rajasthan dominates in solar because of high insolation, clear skies, and vast open land. Then comes wind energy, driven mainly by trade winds and the monsoon system. That is why Gujarat and Tamil Nadu become major wind regions. The map gives you two important associations: Lamba in Gujarat as a major wind center and Tuticorin in Tamil Nadu as another major wind farm zone. Here's the distinction you cannot afford to miss. Solar thermal is for heat. Photovoltaic is for electricity. Now we enter the smaller but high yield category: Niche renewables. First, tidal energy. The location to remember is the Gulf of Kutch, with a projected 900 megawatt plant by NHPC as mentioned here. Second, geothermal energy. This is simply energy derived from the Earth's internal heat. In other words, heat linked to magma and subsurface geothermal activity. The key Indian site you need to remember is Manikaran in Himachal Pradesh. Then the slide gives a historical note. The first attempt at geothermal power is linked here with Boise, USA, 1890. Third, bioenergy. This comes from agricultural residue and waste. That is why it does two things together. It helps clean waste and also generates power. UPSC often ignores these because students ignore them. That's exactly why these become good prelims questions. Now we move to iron and steel. And here, the logic matters more than the list. Iron and steel is a weight-losing industry. That phrase means the finished product weighs much less, or at least becomes economically more valuable relative to the huge mass of raw materials that go into it. Look at the raw material side. Iron ore, coal, and limestone. All of these are bulky and expensive to transport. So the real logic is simple. Heavy raw materials plus high transport cost means the plant must stay close to the mines. That is why the Chota Nagpur Plateau becomes India's steel belt, because it holds the critical combination of iron ore and coal. Don't memorize plant names first. Understand why the industry sits where it sits. Now let's go to the private pioneers of Indian steel. TISCO, ISCO and WISL. TISCO at Jamshedpur was strategically placed near the Subarnarekha river. Its iron ore came from Noa Mundi and its coal came from Jharia. ISCO at Burnpur was located near the Damodar Valley coal belt and its ore came from Singhbham. Then comes VISL at Bhadravati. And this is the outlier you must remember. Why? Because VISL did not begin with coking coal in the normal way. It originally used wood charcoal and later shifted to hydel power from Jog Falls. That makes it the exception, not the rule. And that is exactly the kind of exception UPSC likes to turn into a trap. Now comes the public sector trinity, built during the second five-year plan. These three are Rourkela in Orissa, Bhilai in Chhattisgarh, and Durgapur in West Bengal. Each one has a foreign collaboration, and you must keep them straight. Rourkela was built with German collaboration. Its major support came from Jharia coal and Hirakud power. Bhilai was built with Russian collaboration. Its key ore source was Dalli Rajhara, and the Kolkata-Mumbai rail corridor mattered for connectivity. Durgapur was built with British collaboration, and its biggest locational advantage was simple. It sat directly in the Raniganj coal belt. The mnemonic given is useful because it prevents silly errors. Rourkela to Germany, Bhilai to Russia, Durgapur to Britain. If you mix these up, you lose a question you should never lose. Now we reach the logistics shift, Bokaro and Vizag. First, Bokaro, built with Russian collaboration. The important principle here is the return wagon principle. This means railway wagons should not go back empty. If one raw material moves in one direction, another should move back on the return trip. That is what the diagram is trying to teach. One corridor can carry iron ore one way and coal on the return, reducing empty wagon movement and cutting transport cost. That is industrial geography done intelligently. Then comes the bigger shift, Vizag. Vizag represents a new model because it became the first port-based steel plant, with the slide giving the date as 1992. And once a steel plant becomes port-based, the logic changes. Now location is not controlled only by mines, It also benefits from export-import access, imported coking coal, and maritime transport. That is why Vizag is called a shift in logistics. Now let's move to cotton textiles. The first modern cotton mill in India was established in Mumbai in 1854. And the slide gives you the three reasons: capital, port, and climate. Capital matters because mills need investment. Port matters because raw material and export linkages improve. And climate matters because humid conditions help spinning by reducing yarn breakage. Then comes the shock of 1947, the partition recession. And here lies the real trap. India retained 409 mills, which means the industrial infrastructure largely remained. But it retained only 29% of the cotton growing area, meaning the raw material base was sharply reduced. So the problem after partition was not only political division, it was a serious raw material imbalance. Infrastructure stayed, raw cotton supply shrank. That is a very exam-worthy contrast. Now let's compare the location logic of iron ore and cotton. This is one of the most important conceptual distinctions in the file. Iron ore is a gross or weight-losing material. That means the industry must stay near the mine because raw material transport is costly. Cotton is different. It is a pure, non-weight-losing material. The slide gives the logic in one line. 1 ton of raw cotton gives roughly 1 ton of cloth. So transport cost does not strongly force the mill to remain near the field. That changes everything. Now cotton mills can move toward market, labor, or power, not just toward cotton growing regions. This is where many students overgeneralize resource-based industries. Not every industry behaves like iron and steel. Now let's see how that logic plays out regionally. In Uttar Pradesh, the key example is Kanpur, and it is described here as a market-based industry. That means the locational pull comes more from market demand than from cotton fields. In the West, the older dominance of Mumbai declines because of problems like space constraints and labor unions, and activity shifts toward Bhiwandi. Then in the South, Tamil Nadu emerges as the leader. But notice the important qualifier. Tamil Nadu leads mainly in yarn production, in other words, spinning, not necessarily finished cloth dominance in every case. And the power base matters. The slide links Tamil Nadu's advantage with hydropower. So this is not just a north versus south story. It is a story of how location shifts once the industry is free from raw material compulsion. Now consolidate through the revision checklist. You need 6 clean anchors. First, the first cotton mill, Mumbai 1854. Second, the first atomic institute, Trombay 1954. Third, the first port-based steel plant, Vizag 1992. Fourth, the collaborations, Rourkela with Germany, Bhilai with Russia, Durgapur with the UK. Fifth, the mineral contrast, uranium equals inland rocks, thorium equals coastal sands. And sixth, the renewable associations, Lamba equals wind, Manikaran equals geothermal. This is how toppers revise, with anchors, not paragraphs. Now the final trap alerts. First trap. Do not confuse the Atomic Energy Commission 1948 with BARC 1967. Commission came much earlier. BARC came later. Second trap. VISL is the only major steel plant here that did not begin with coking coal. It used charcoal and it is located in Bhadravati, Karnataka. Third trap. Solar energy is not one thing. It includes photovoltaic for electricity and thermal for heat. Fourth trap. In textiles, the organized sector is tiny, just 6% here. The real dominance lies with power looms, the decentralized sector, shown here at 59%. Handlooms are 19%, and others 16%. That means decentralized textile production is much larger than many students assume. If you lock these traps properly, this chapter stops being confusing and you are exam ready.